Okay, want to find out where this thing's not continuous and explain which conditions of continuity are not met. So this is a piecewise function, and the very first thing you should do if you're asked to do this for a piecewise function is look at each individual piece. We've got 2x plus 3, which is continuous everywhere because it's a line. So there's no problems on that one. X plus 4x squared is continuous everywhere. That's a polynomial. It's a quadratic. That's continuous everywhere. 1/2 x plus 8 is a line. That's also continuous everywhere. And 3x squared plus 6, also continuous everywhere. So each one of these individual functions is continuous everywhere. So they don't really pose any problems by themselves for continuity. The problems happen where we switch functions. Okay? They're called joints or the switches or the jumps, whatever you want to call them. So you can see here, 2x plus 3 is going to be defined for f of x up until you get to 1. And that one, it switches over to this function. So we need to look at these joints. We got to look at what's happening when the function's switching, when f of x is switching from one part to the next part. So again, we're checking, is the function defined? Does the limit exist? And are they the same thing? So at 1, you can see the function's going from 2x plus 3, and it's switching over to 4x squared plus x. Well, right away, you can notice here that nowhere on these the switch do we have an equals 1. Like there's no equal bar underneath here, you know? So what that means really is if I ask you to find f of 1, if I say, hey kids, what's f of 1? You're going to try and plug 1 in, but first you got to find out where to plug it in. Well, you can't plug it into this top part because this is only works when x is less than 1. Well, 1 is not less than 1, so you can't plug into there. You can't plug into the second part because that only works for x greater than 1 and less than 2. Well, 1's not in that interval either. So f of 1 is just not defined by this piecewise function. Well, f of 1 is not defined, so this function's not continuous at x equals 1. And that's the reason, because f of 1 is undefined. There's no point at 1. Okay? So that was pretty easy. And now we can check the next split, which is at 2. So this function takes over at 1, x plus 4x squared, and it's going to continue all the way up until 2. It has a very short lifespan here. So at 2, the function equals this line, which is just 1 point. So technically, we can just say that this thing's going to equal, because it only happens when x is 2. When you plug 2 into here, you get 9. Okay, so this thing only equals this function at 2, which means it's 9. So there's just 1 point there. And then after 2, this part takes over. So we got to see, first off, does each side approach each other? And do the sides, if they do approach each other, do they equal what the function equals, 9 at 2? So we're going to check out x equals 2. Now, I don't know if it's going to be continuous there or not. So what I'm going to do is check out the left-hand limit. The limit as x approaches 2 from the left of f of x. Well, for any value a little bit less than 2, we're going to be on this interval here. And as x gets close to 2, it's on this function, x plus 4x squared. So this function has to be getting close to 2 squared is 4 times 4 is 16 plus 2 is 18. Okay, so as x approaches 2 from below, f of x is headed towards 18. Well, right away, we know that this is no longer going to be continuous because at 2 it equals 9. From the left, it equals 18, and when it gets to 2, it equals 9. What that means is happening at 2, if you think about it like this, at 2, the function's headed towards 18, way up here. Okay, let's say that's 18. That's where the function's headed. But when it gets there, it equals 9. Well, it can't be continuous. No matter what happens on this other side, it cannot be continuous. But just to finish this up, we'll check the right-hand limit, just so we can write it a little bit more concisely. So we're going to check the right-hand limit of f of x. As x approaches 2 from the right, we're on this function here, 3x squared plus 6. And 2 squared is 4 times 3 is 12 plus 6 is 18. Okay, so the left-hand limit equals the right-hand limit. That's good. But that limit, which is 18, does not equal the function 9. So at x equals 2, it's not continuous, and the reason is the limit as x approaches 2 of f of x equals 18. Okay, the limit equals 18 because both sides approach 18, but that does not equal f of 2, which equals 9. So since the limit doesn't equal the function, we have this going on. This thing headed towards 18, but when it gets there, boom, it equals 9, and then after 2, boom, it equals 18, or it's close to 18 again, and it heads off. So not continuous. So those are our two points. X equals 1, x equals 2, and this is the reason for x equals 2 right here.